So what we're going to look at today is an application problem of cones, and in this problem we're going to have two shake cups from a restaurant. So here's what the cups look like. Alright, it's a large one, a small one. The large cup is $5.89, and the small one is $3.49. We want to figure out what the better deal is, so we need to calculate the volume of each cup and divide it out, compared to the price, and see what the price is per cubic centimeter of each cup. So this is on the upper end type of problem that you'll see on your homework, one of the challenge problems. But it's really a multi-step problem. It's not too bad, just lots of steps. So we have the diameter of each top of each cup, and we're given the side length of each cup as well. So the small one has a side length of 12 centimeters. If they would have given us the height, this problem would be a lot easier. Well, not necessarily easier, but it'll take less time. But they didn't give us the height here, right? They only gave us the side length. The side length is not the height. So h is unknown for each one of them. Alright, so let's figure out what h is first, and then once we do that, we'll basically have the problem solved. Okay, so here's our large one. There's our small one. The length across the large was 10 centimeters. The length across the bottom one was 7 centimeters. And we had the diagonal distance, which was 12 centimeters. And that diagonal distance was 15 centimeters. So what we're going to do here is form a right triangle from the center of the cup down to the bottom. So we're going to have a triangle like this and a smaller triangle like that. It's important to realize that the top of the triangle is from the radius outwards, because from the center of the cup. 10 centimeters is the diameter. So we cut that in half on the left. Get 5. I'm going to just stop using units for now. And then we'll put the units on at the end. And that's going to be 3.5 on that one. The next thing we're going to see is the diagonal length of the side, which is given to us as 15 centimeters. And the other one was 12 centimeters. So we're going to figure out what that h is on each one. And all we have to do is the Pythagorean theorem. So let's rewrite that triangle. It's going to be h. The top of this one was 5. Side length was 15. And the top 3.5 and 12. Alright, so we can do the Pythagorean theorem here. So remember, a squared plus b squared equals c squared. And on both sides, we'll do it both together. B squared equals c squared. So let's call a squared the height side. That's my a. That'll be my b. That'll be my c, because the hypotenuse is always the c. A, B, C. Alright. So a is h, so it's h squared. B squared, that's 5 squared. And c squared is 15 squared. H squared plus 3.5 squared equals 12 squared. All right, so we're gonna have h squared, when we subtract 5 squared from both sides, when we subtract that out, that's gonna cancel, and h squared will actually end up equaling 200. And when we subtract 3.5 squared from both sides, okay, we're gonna get h squared equals, when we do 12 squared, which is 144, minus 3.5 squared, well that's 3.5 squared, and you're allowed to use your calculator. It's going to be a little over 10. What we'll get is 131.75. And the last thing we need to do is take the square root of both sides. Because we have h squared, we just want h. So let's rewrite this on another slide here. Take the square root of 200. Before we do that, actually, remember that the square root and a square root cancel each other. And the square root, that's why we're doing it, because they're inverse operations. So on the left side, we'll get h is going to be approximately 14.1. And the right side's h is going to be approximately 11.5. Alright, so now we have the height of the cones. So what we can do now is figure out the volumes. Alright. So now we found the height. Which one? This one was 14.1, and this height was 11.5. And we had the diameter that we saw from the last problems divided by 2. So the diameter given to us here was 10 centimeters, and the other one was 7 centimeters. So we cut those diameters in half to find the radius to make these triangles. So the radius of the larger cup is 5. The radius of the smaller cup was 3.5. And that's basically all we need here to do this calculation. Alright, so let's go to another slide. Let's just do both volumes at the same time. Volume of the large cup is 1/3 capital B times H. Volume of the small cup, 1/3 capital B times H. Alright, so capital B here is the circle, since they're cones. So we're going to have 1/3 pi r squared times h. And that's the h we just found with the Pythagorean theorem. Pi r squared times h. Alright, so r we just saw was 5. R is 3.5 for that one. Well, 5 squared h, 14.1, 1/3 pi, and r was 3.5 for that one, so it's 3.5 squared, and h was 11.5. 11.5. Let's write that a little smaller. So 11.5. We're going to that's our H. All right. So when we punch those in our calculator, what we'll get is the volume of the large cup is approximately 369.1. And that units where we'll go back to our units now. It's cubic centimeters. The volume on the right is 147.5 cubic centimeters. So we're not done yet. We found the volume of the cups. So now we got to divide the price by the volume to see what the price is per individual cubic centimeter. All right, so remember the large cup had a price of $5.89. Small cup had a price of $3.49. So we're going to divide it out by the volume that we just calculated, 369.1 centimeters cubed and 147.5 centimeters cubed. So we have a unit price of 0.016 dollars per cubic centimeter, and the other one is approximately 0.024 dollars per cubic centimeter. So it looks like the large cup does cost less here. It's not much less, but it is less, and that's nice to see that, because sometimes when you go into a place and you look at the price and you're like, I wonder if that's really, should I get two smalls, or that kind of thing. And here we showed you how you can do that calculation on your own.